All right, we are about to jump into the story of one of the most powerful ideas in all of history. It's a tale of mystery, of pure genius, and, well, it's about a number that literally goes on forever.
So let me start with a big question for you. If you had to pick just one number, the single most important number in the entire universe, what would you choose?
I mean, you could make a pretty good case for the number one, right? It's the start of everything. It's the basis for all counting. A totally solid choice.
Or what about zero? You know, that's a concept that took us thousands of years to really wrap our heads around. It completely revolutionized math, giving us a symbol for, well, nothing, but also a placeholder that makes everything else work.
But there's another contender. And this one's different. It's not just a value. It's more like an endless process, a number that actually has a kind of infinity baked right into it.
Yep, we're talking about pi. And honestly, its story is really the story of how we, as a species, finally learned to get a handle on the idea of infinity itself. You have to understand, for most of history, pi wasn't just some number you could look up. It was a puzzle. It was this endless chase. Now, on the surface, the definition seems pretty simple, right? You take any circle, you measure the distance around it, the circumference, and you divide it by the distance across it, the diameter. Boom, pi. But here's the crazy part. The thing that drove mathematicians nuts for centuries. The number you get is irrational. The digits just keep going, forever, with no pattern.
So for thousands of years, this was the game. And progress was, well, let's just say it was glacial. I mean, the Babylonians got kind of close. Then you have Archimedes, who came up with this brilliant idea of trapping pi between two shapes. Ptolemy made it a little better. But you see the pattern here, don't you? All of these, they were just approximations, an incredibly slow, painful process of just getting a little bit closer, but never actually getting there.
And then everything changed. In the 15th century, the whole game got turned on its head. And the big breakthrough? It came from a place that might really surprise you. Yeah, this was a huge historical shift. The real leap forward, the key that was going to finally unlock this whole infinity problem, it didn't come from ancient Greece or Renaissance Europe. Nope. It came from the Kerala school of astronomy and mathematics, all the way back in 15th century India. And this is the crucial difference. You see, the ancient world was stuck on approximation. They were just drawing more and more complicated shapes to try and box pi in. But the Kerala school, they developed a method for actual calculation. They figured out a recipe that could generate the digits of pi one after another for as long as you wanted. So what was their secret weapon? It was a whole new way of thinking called the infinite series. And the basic idea is actually something you can wrap your head around pretty easily. Okay, picture this. You're standing 1 meter away from a wall. Now, walk half the distance to it. Okay, now walk half of the remaining distance, and then half of that tiny distance. You could do this forever, right? Adding an infinite number of smaller and smaller steps. But you end up getting perfectly, exactly 1 meter closer to the wall. And that's what they did for pi. We know from texts like the Yukthabasha Shah that these mathematicians found the exact recipe. A specific series of adding this, subtracting that, on and on forever that would land you perfectly on the value of pi. This was a total game changer. For the first time ever, pi wasn't some fuzzy measurement. It was an exact number you could calculate from an infinite but perfectly orderly process.
Okay, so let's fast forward a couple of centuries and jump over to Europe, because this idea, this ability to tame the infinite, was about to kick off an absolute revolution in math.
So over in 17th century England, a mathematician named John Wallis finds something just wild. He figures out how to get pi not by adding an infinite bunch of numbers, but by multiplying them. He comes up with this beautiful infinite product, this cascade of fractions that just equals pi. It was proof that there wasn't just one road to infinity. And then came Isaac Newton. And of course, Newton takes this whole thing to another level. He starts with a simple circle, but then he uses his brand new powerhouse tools, calculus and the binomial theorem, to turn that shape into pure algebra. And when he summed up that series to find the area, bam, out pops pi. He showed that infinite series were the magic bridge connecting the world of shapes with the world of equations. You can't overstate how huge this was.
The old ways, they were stuck with circles and squares. Newton's method, using series, could find the area under almost any curve you could write an equation for. So the search for pi didn't just solve one ancient puzzle. It ended up giving us this universal tool for understanding, well, pretty much everything. Okay, so if Newton kicked the door open, the guy who came next, Leonhard Euler, he basically strode right through it and declared himself king. This 18th century Swiss mathematician was the undisputed master of infinity.
So Euler decides to tackle this famous problem that had stumped everybody, the Basel problem. The question seems so simple. What happens if you add up 1 plus 1 over 4 plus 1 over 9 plus 1 over 16, the reciprocals of all the perfect squares, forever? Everyone could see the answer was getting closer to some specific number, but for the life of them, nobody could figure out exactly what that number was.
I mean, the best mathematical minds on the planet had been beating their heads against this wall for decades. It looked impossible. And then comes Euler, with his insane mastery of infinite series, and he just solves it. And the answer? It's pi squared divided by 6. Just let that sink in. A problem that has absolutely nothing to do with circles, it's just about adding up fractions, has pi at its core. This was just a mind-blowing revelation. It proved that pi wasn't just about geometry. It's some kind of fundamental constant woven into the very fabric of mathematics itself.
So this is a great story, but why does any of this matter to you and me today? Well, because that tool they invented to hunt down pi, the infinite series, is quite literally everywhere. Think of infinite series as the hidden engine running our entire modern world. You know, the way your phone compresses music and video? That's infinite series at work. The incredible computer graphics you see in video games, that's series, building perfect curves out of simple math. Physics, engineering, even financial markets, this thing that started as a totally abstract idea is now one of the most practical tools we have. So this whole centuries-long hunt for a single number forced us to stare into the abyss of infinity, and eventually to master it. It gave us a powerful new language to describe the universe. And that leaves us with a pretty amazing question to think about, doesn't it? Now that we've learned how to speak this language of the infinite, what other secrets of the universe are we going to unlock with it next?